This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
So welcome to the Math Map Book Club. Today is Wednesday, August 12th. As usual, we're on here on a Wednesday, and I'm super excited to see our polymath, Kirsty Gilpin, as she leads us in math today with a broken leg. Tell us all about it, Kirsty.
Well, actually, everybody's going to be able to watch all about it because I fell on a beach in Wales and required the ambulance service, the Coast Guard, and the Royal Lifeboat Service to rescue me from the beach. And it was all filmed by the BBC for their show, SOS Extreme Rescues. So sometime in early 2027, you'll all be able to see the dramatic rescue on the beach in Wales of me with my broken leg.
Okay, my only question, did you get to say classical conversation somewhere in there?
Well, interestingly enough, their primary or their first response to deal with my pain was laughing gas. And so I guess while I was under the effect of the laughing gas, I kept telling them how great math was and that they needed to make sure that they included that in the recording. So I don't know that I got CC in there, but I definitely got the fact that math is so great in there.
We probably need to include laughing gas in the manipulative kit, the next edition of that, that would help.
Good idea, Eugene.
Yeah, it was an experience, but praise the Lord, we are home safely, and I cannot say how thankful I am because most of the people that were there to carry me off that beach were volunteers, so they were people that all dropped what they were doing and came down to help me out, and I am really, really grateful. So the irony of it is that Kate and I were actually trying to fill in holes so that nobody would get hurt by stepping in them. Yeah. So, but I did have an amazing trip to the UK, and I had an amazing time meeting with some of our UK families. And in a tiny little town in Wales, I actually bumped into a couple, and somehow the subject of homeschooling came up, and they said, "Oh, our son homeschools in another city, and he uses a program called Classical Conversations." And I said, "Well, isn't this a small world?" So that was really fun.
That's great. Okay.
So today's lesson is about comparison, and it was interesting because that was one of the things that I did a lot of, was comparing how the U.S. response and the British response to things was different. And so when we think about equipping our students to compare, right, we're always comparing things, not just numbers, not just mathematics, but when we look at mathematics, not only can we use comparison to find patterns and learn more about the math that we're studying, but we can also practice comparison on numbers, practice comparison using mathematics, and so that we are well equipped to compare in other areas of our life. And I think that's just a really great reminder that when we're looking at these skills, the way that we're equipping our children, we are equipping them for more than just learning mathematics, right? That mathematics is a great medium for us to be able to equip them to know how to learn all things. All right, so Babs, do you want to move our slides along? So as we look here, we're not going to include this every week, but I really want, for those of you who are new to joining us on the book club, I really want you to know where you can find these resources. And your primary resource for extra things is the companion. And so each week we're going to highlight a little bit of something in the companion at the end. So watch for that. And then our book club archive. There's so much great information it can be overwhelming if you are new to the math map and you see that there's all these hours and hours of videos to watch. So I wanted to point out that you might want to break it down by whether you're looking for help with the exordium and the charts, whether you are looking for the in-community outline, or whether you're looking for help with the at-home outline. Those are three major places that you can go and look. This year's, we're looking at what does it mean to use our classical tools on the lesson pages, and then your best resource for figuring out exactly which of these videos is going to be the most helpful. If you can't find the one that you're looking for, is you can always email us at themathmap@classicalconversations.com. So let's go ahead and jump into this week in comparison. Just as a reminder, we're looking at pages 5 through 8, and we may not get through all of them because we are looking at this classically, and so we may not get through every page, and that's okay. Last week, what we decided we were going to do to start off is to take a look at the tops of our pages. If we have multiple students, we can look at the tops of those pages together with our students. That's a great way to introduce those ideas and look at them together. So everybody go ahead and take a quick look at the top of page 5 from Rationals and Binomials. At a minimum, I would encourage you to read the instructions together, especially at the beginning of the year. And then give your students a minute to think about what is familiar and what is unfamiliar. So go ahead and pop in the chat some things that as you look at these pages, what's something that might pop out to you and you're like, oh, I'm familiar with that. Or jot down something that feels unfamiliar to you. Once you've looked and scanned and looked for some things that are some familiar or unfamiliar, go ahead and compare. So compare your domain to somebody else's domain. What's the same and what is different? And you can pop that in your chat as well if you would like.
Percy, I'm just thinking for sake of time, you might want to start reading them even while people are still answering.
Yeah. So, well, what I'm going to ask now is for somebody, I'm on my phone, so I can't look at the chat as easily. But if somebody would like to pick something that somebody's put in there as something that feels unfamiliar to them, if you go, oh, I'm familiar. So I need a volunteer familiar student to pick one of those unfamiliar things and tell us how did it become familiar to you? Or how do you understand it? See if you can come up with how would you help somebody if they came to you and said, Jana, okay, will somebody be brave and say something that's unfamiliar? Or maybe there isn't anything.
I think I can answer your question. I think when I first saw this, I was immediately, first of all, I didn't read the instructions. So I was immediately putting greater than, or looking to put greater than and equal than into those circles. And then I kind of went up and I looked at the circles and then I went to the directions, which you should do first, obviously. And then I was stuck like, oh, now I have to remember what these symbols mean. And then I went through my mental Rolodex of the flashcards. And so now having done some of those flashcards, I know the words superset and subset, and then I worked my way back down. And so that was my process of figuring out what the heck I was looking at.
Well, that's great. So Nicole, you could have done that, right? If another mom had come to you and said, this feels really unfamiliar. I love the way that you said, this was my approach. You didn't feel that you had to be the subject matter expert and explain it, but you said, hey, this is how I approached it, so that you're helping bring that unfamiliar student along, following in your footsteps. Do you think that our students can do that for one another, especially if we have students that are a little bit older?
I think so. I think one of the best things a mom can do with the math map is have one of their older students looking at the younger students' domain and helping them. That's even better to do than their own domain. Because when you teach, you have to learn.
Yep. That's exactly it. So I think that that's a great opportunity when you're sitting down with multiple students and you're looking at those page tops, and that more familiar student works with a less familiar student, and that might flop. Most of the time, we would expect that it's going to be your older student who says to the younger student, "Hey, this is what this means," or "You can go and look here." But sometimes you might find that the younger student goes, "Well, I know what that pattern is. Look, I saw this pattern," because they're maybe not trying to be dialectic or understand it all or think more highly of it. And so you might actually see that flip flop sometimes, and that your younger student might be the one that feels more familiar with the material. And that's a great way to encourage them as well in their learning. So let's go ahead and look at the rest of page 5 with the rationals.
One of the words in the instructions is, I mean, you know me, closure. I kept wrestling with that and doing the problems wrong and coming back to Kirsty. And like I intuited what it was, but as you put in each of the various domains, practicing through naturals or rationals or complex, boy, I could confuse myself in a second. So it was going back to it over and over again, which is, of course, why the curriculum is designed to see it again every year and not assume it's easy.
That's a really great reminder that simple things are not always easy things.
Mm-hmm.
And that sometimes we can think we've intuited something, but exactly what you just said, Lee, once we come around and try to explain that to somebody, it becomes a little bit harder. So as we're waiting for this slide to click over here, I know that there we go, right? As I said, we're going to flip back and forth. So we're going to look at one of our pages with rationals, and we'll look at the next page with binomials, getting through as much as we can. Again, I would start off by reading the page with my student or encouraging them to read it, at a minimum, reading my instructions. Remember that the language of math is required for us to really be able to do anything else. And so if we skip ahead without learning the language, then what ends up happening to us is that our students are just frustrated. I saw an analogy to this, and I forget where I read it. It was somewhere in our travels, something popped up on my phone. And the analogy was that if you have a student and you think, well, they're 10 years old, they should be able to swim by now. And so you push them into the deep end of the pool. Right? That's not what we do, right? We don't go, well, you should be able to do this, and so we're just going to push you into the deep end of the pool. It doesn't matter. Well, don't worry. I know you couldn't swim in 6 feet of water, but maybe you can swim in 10. Right? Nobody would ever do that. But yet sometimes we do that with mathematics because, yeah, Andy, that's funny. Sink or swim. But sometimes we're tempted to do that with math. I don't know what that symbol means. Well, that's okay. Just go ahead and do the work, right? Don't worry about it. Just do the work. And so we push kids and they just get more and more frustrated. And so when we come back and we go, hey, the most important thing is knowing the language, we don't mean it's the only important thing. But we recognize that if you can't speak the language of mathematics, if you can't read it and know what the symbols mean and know what the words mean, then you really can't progress. So when we say read and it's important, we mean that it's fundamental, it's elementary, it's essential to developing mathematical understanding is being able to read that language. So not the only thing, but it is an important thing. And so that's why we start. Every one of these says start by reading. Make sure your students know what that page says to them. Then let's attend and say what's familiar and what's unfamiliar. So you don't all have to do it, but pick something on this page that is unfamiliar and drop that in the chat. And if there's nothing unfamiliar, then hey, that's a great thing because that means we're winning. Lee says symmetry and the reflexive feels unfamiliar. All right. Well, let's pick that and then let's practice our skills. So let's look at those two lines where it says reflexive and symmetry and tell me, what do you know? Name the things there that you know.
So for me, that would be part of the problem because reflexive and symmetry feel like they're the same word. And now you're giving me different images. So I have to go, oh, reflexive is literally exactly the same. Yeah, it's exactly the same. It's not a reflection. It's exactly the same. Based on these
It's not a reflection?
No, because otherwise your two would flip.
That would be symmetry.
Yeah.
No, symmetry looks different.
Mm-hmm.
Symmetry is just equal too, but
okay,
reflexive,
so you guys are,
think
okay, did I ask for a comparison yet? So when your kids start doing this, right, are we comparing?
Well, that's what my question was. Versus, not and. It's the comparison. Right, your brain always compares to determine familiarity. You have to.
Well, so we're going to start by naming. So look at that first row and just name the things that you see. What are some things that you know?
On that? I see a domino and an equal sign and a 5 domino.
Okay, good. So I know that those are dominoes. I can see that there's 2 dominoes, there's 5 dominoes. I see that there's an equal sign. Good. Okay, so now look at the symmetry row, and what can you name?
You can name that the one domino has 2 in one space and a 0 in the other space, and then the domino on the other side of the equal sign, on the right side of the equal sign, has a 1 in one space and a 1 in the other space, so they both equal the same value, but they are not arranged the same way.
Good. I like that.
In the first row, there's nothing connecting the 2 different sets of dominoes, but in the second one, it's an if-then statement, like they have a relationship to each other.
Okay, good. So we see so we've been able to name what the dominoes are. We've been able to name some symbols. We've been able to name if and then. We've been able, now we might start looking at defining, and we might look at that and go, well, I'm not sure, but you might say, okay, well, define that space. And Jana just said, well, there's nothing connecting. There's actually 2 examples in the first line, and there's only 1 example in the second. So now we're sort of getting into the comparison thing here, right? We're comparing the idea of the familiar, where we had 2 dots, and maybe the idea that there's 2 dots, but now in 2 spots. So now we're using some comparison to compare those different things. So now let's look at the patterns. All right, I'm going to attend to my patterns. And if I'm attending to my patterns in that first row, right, what do we see? The first, what's true on both sides of the equal sign?
Exactly the same.
They're exactly the same, right?
And they're oriented.
Both of those examples.
And they're oriented this. I mean, I guess it wouldn't matter, right? If it was a.
That's what I would like to know. Would it matter with the reflexive if you flip the domino?
That's a really good question, and I would say yes. It probably would matter, because the idea behind the reflexive is that we have one thing is equal to itself.
Dr.
Right?
Gilpin, we're thinking about that because when I approached this, you talked about definition. My first question would ask, what is reflexive? Is this, now we're just trying to look at a pattern and they answer the question, but is that like for parents, do they go to the glossary? Like, and then with that word being there, and then they can define it for the kids, or what would be the best practice here to do what we're doing right now, or say, here, this is a definition of reflexive, and then see if you can make sense from the dominoes. What do we do? Well, do we do the top down or the bottom up?
So I would say it's going to depend on the circumstance. So in this case, we're taking a look and we're trying to help our students to really kind of come up with the definition themselves. Right? So we're almost inviting them to look and see what the pattern is and then say, so what do you think reflexive means? Right? So we've just said that the domino on the left and the right is the same for both the first example and the second example. So then I might say to my student, what do you think reflexive means? And see if they can define it as that you have the same thing on both sides of the equal sign. That would be, you're going to choose some things to dive in that way and say, okay, now help me, right? Do you see this? And now maybe let's go look it up and see if that matches our definition. I would start with the charts before I jump to the glossary. If the charts don't help me, then I would go to the glossary. Now, sometimes I might, and one of the things we're going to continue to emphasize is that we cannot do this with every unfamiliar thing on every page, right? We've picked one thing on this page. So lots of people said there were lots of things that were unfamiliar. Now, it may be, Lee said, I want to understand the difference between reflexive and symmetry. So maybe we're taking a deep dive and we're looking at both of them and we're going to compare one to the other to see what the difference is. But it may be that all we did was reflexive. And so I'm going to ask my students to name what they know. Is there anything you need to have defined? No, we know what all these symbols mean. It's just this word I'm working on. Okay, so what do you see here? Well, the dominoes are familiar to me, right? Mm-hmm. And maybe they're like numbers, right? So what's the pattern? Okay, do you remember any other laws? Well, that's what I'm trying to define is this law. So now what do you think it means? That takes time, and we're not going to be able to do that for every single unfamiliar thing that we encounter every year. But I would encourage you to pick one or two things each day and go through that with your students. Now, there might be, right, if let's say I heard somebody say transitive was something that felt unfamiliar to them still. Well, if we've just gone through this process with the reflexive and the symmetry, I might say, okay, we're not going to go through that same process with transitive together, but I'm going to give you a few minutes to go through that and see if you can figure it out. Or I might say, okay, for the other things that are unfamiliar, we're going to just go ahead and look at the charts and see if there's a definition, or we're going to look at the glossary and see if there's a definition. And we can be didactic in places, right? We can be didactic in places, giving our students those definitions that they need, but we want to pick out some things to really help lead them through this classical process of learning so that they can then apply that, right, to other things. So this is how we're going to build them up, is by picking one or two unfamiliar things and working through this. Does that help you, Yating, to give you sort of an idea about how you could maybe use that?
Oh, yes. Thank you. And I like what Lee said in the comments, that there are different places to look before we go didactic. But I like the fact that, in real life battle, we're picking and choosing. Where do we want to be didactic and where can we actually infuse classical skills?
Yeah. And I think, we keep getting from people, especially people that are new to the math map, we keep getting people saying, we want a script, right? Tell us. We want the script to tell us what to say and when to say it. And we keep saying we can't, because Yating's children are going to be different than Nicole's children, are going to be different from Jana's children. And they might all have different questions. And your life might be different, right? So, right, I broke my leg on Friday. And now, I found out this morning there's a chance I might have to have surgery, right? So if I was still actively homeschooling, this might be the time where I tell my kids, look, just go look on the charts and read it and see if you can figure it out. And mom will just, we'll catch up in a couple of weeks. Right. All of us have life going on as well as having different children. And so we really want you to be equipped to have these conversations where they're where they're going to bear the most fruit, and also feel as though you have the support with the information you need when you kind of just need to be a little bit.
So one of the things people don't pay attention to is if you look at digits, naturals, and integers, at the bottom of the pages, it says the word read the symbols, read the words, read the images. Because to give the parent the idea that it doesn't matter which of those three you pick, you look at the page and every day just pick one thing to work on. So that's why, so you're practicing the script when your children are babies. And then if you're not sure of how to do it, you can practice the script by getting the naturals, which we had for years available to people. So it's like the reading and the process is important. There are no shortcuts.
I wish there were.
I mean, what's the shortcut to me learning how to play the piano besides sitting there for hours?
I wish we had, Harry Potter magic where she just gives you that nasty tasting juice, the polygrow, and your bones fuse back together. We would all like the shortcuts. Mm-hmm. All right. Well, let's take a look at our next page together. And you're going to see we're just going to keep looking at these with the same questions. So take a look here and go ahead and note something that's unfamiliar. And if somebody puts something in the comments that is unfamiliar and you think you can explain it, go ahead and jump in and be that familiar student helping them.
This is a side note, and it's probably completely irrelevant, but these conversations at home make me want to take 2 weeks for each week. And it's like really frustrating that I'm trying to keep up with community because I think that's a super great asset. And at the same time, I just want to sit on these for just a little bit longer.
Well, and that's one of the great things about being able to come back the next year. And so I would encourage you where you're like, oh, this would be a great conversation. Use the charts to highlight and leave notes for yourself, especially if you have more than one child. Take one of their sets of the charts or save one from previous years and use that to make some notes so that the next year you can come back and go, oh, that's right. We had a really great discussion about this and I wanted to go farther. Or at a break, you can go back and look at those notes for things you wanted to go a little bit deeper on. All right. So Lee says she's unfamiliar with bracket notation. So who thinks that maybe they could maybe help her to make a connection and understand what the brackets mean in the interval notation? Does anybody feel like they know what that means?
I can't spot the brackets she's talking about. What brackets is she talking about?
In the binomials, under the plot the intervals.
I know that there is a relationship between whether it's a bracket versus a parentheses, whether or not the dot is open or closed.
Good. Do you remember which one is which?
So on my booklet, I'm looking at my comparison binomials booklet. It has beside the word plot intervals, it has a square bracket with a circle that's filled in, and then the parentheses type brackets with the circle not filled in. But that's not what's on the screen.
But you can see the example of the numbers that are given underneath. Like if you're comparing the top set with the bottom set, okay, we see that the top one has those squarish brackets, and your example says that negative 1.1 is less than or equal to. So that would be the filled in dot, right? It could be equal to. But the next one down, it just says less than. So that would be our open dot.
Very good.
Oh, look at you attending.
And you might have an older version, Kristen. Or Kirsty could have the older version. I don't remember which had the extra information.
I just May. early night, whenever they went on, whenever they started selling.
So you probably have the newer one. I'm making a
check
note
it.
to double check. So
I'll make sure that I've got the most up to date next week. So notice I didn't teach you anything. Lee didn't teach you anything. Nobody stood up and said, "Oh, I'm a subject matter expert," but you all were able to use your classical skills to say, "Look at this. I remember there was a connection," right? So we used memoria, we used comparison, we used definition. So could one student or two students working together, looking at this, be able to make some of those connections? Yeah. And that's what we mean by the classical method, is that we don't jump to the didactic, right? The didactic isn't always bad, right? We know that we need some of that to give us our language. But when we're looking at this, the student who makes those connections is going to really understand, right? They're using grammar that they know, bracket, parentheses, right? They know those terms. So that's grammar that they already know. They're using that to compare to grammar that they also know, less than or equal to or less than. And when they compare the two and they say, "Oh, these must mean the same thing," right? Now they're actually, that's that dialectic moment because they're figuring something out. And as parents, we can lead them, right? They aren't not necessarily always going to automatically do that themselves, but we can lead them by saying, "Well, compare that first line to that second line. Let me read it," right? X is an element, right, of the set from negative 1.1 to 1.2. And let's read the next one. Negative 1.1 is less than or equal to X, which is less than or equal to 1.1. Okay, I want you to, what do you see that's the same between those? And then you could even sort of hint to them by saying, "Well, how many lines are there to the right to plot the solution?" "Oh, there's only one." "So do you think that these are two ways of expressing the same interval?" "I would think probably." "Okay, so what do these different symbols mean?" And we're asking those questions to help them make those connections. Any other questions on this page?
And I just want to add that we're also attending to help ourselves make these connections, so we might not be very far ahead of them, and that's I am trusting that that's okay.
It is absolutely okay. All right, so let's look at the next page.
I'll share a story real quick. I was correcting a paper of David's, and I wanted him to use some commas. And he was like 11, and he looked at me and said, "Mom, it's a who-which clause. I don't need commas." Like, that's what we want them saying to us.
Yeah, and that's it, right. Our kids might know more than us, and that's okay.
But that's when I'll say you might be right, but you need to be kind. There are wrong ways to be right.
Yes.
That's actually, it's in the Parents' Introduction to the Reasoning Together book, Fallacy. So I thought I just want to use that for my kid. I said, I'll steal that.
Well, it's so true, because the character side of homeschooling really should come first. And sometimes it's easy to jump into the content side of homeschooling and skip that character side. But if we don't deal with the character side, the content won't follow as easily. So it's always a good idea to take time for that character side, and then let the content follow. All right, so let's take a look here at page 6 on binomials. And again, I would encourage you to read through that. And then we're going to go through and say what's familiar and unfamiliar. So let's go ahead, and if there's something unfamiliar on that page to you, go ahead and pick out some things that that might be unfamiliar and drop those in the chat, and then we're going to pick one of those to talk about a little bit more in depth. All right, sine, cosine, and tangent. That's a fun one, because we're not actually in that lesson, but if we have a student who's been through the math map, they would have seen that before and may not remember. So let's take a look at that row where we have sine, tangent, and cosine going across. And as we look at that row, let's name some things. What are the things that you do know on that row?
Fractions.
Okay, there's some fractions. Degrees. Okay.
And that sine of 67 degrees is my units behind my 2 9ths. And tangent 45 is my units behind my 42 6. So and cosine 30 is my unit behind 1 that's invisible.
Good. So Lee's pointed out something really important here, that do we need to know what sine, cosine, and tangent mean in able to be able to evaluate these?
Not really.
No, you could just replace them with A or X or anything.
Mm-hmm.
So
the only place, I just realized the only place that's not true, Kirsty, is if they'd all been greater than 90 degrees, we might have.
I was just going to say.
Oh, okay.
Yeah, I was just going to say. So it could be an issue if they represented a negative value. That's where it could be an issue. So, but let's assume that they're all positive, which these are. And so for our student that's going, I don't remember that. As a parent, if you don't have time to dive down deep, you can always say to them, okay, well, if it's sine of 67 on both sides, what's the part that's different? Well, 2 9ths and 1/3. Okay, so don't worry about the sine, cosine, and tangent part. Just look at the fractional part and compare those. So if you're a parent that's going, I don't have time to dive deep, that's one thing that I can tell them is look at just the fractional part and compare those. If we do have time, right, I might go, okay, so some of the things that you just said you could name were degrees. What do we use degrees to measure?
Temperature.
Angles.
Temperature and angles most commonly. Have you ever heard of like sine, cosine, and tangent when we're talking about the weather?
No.
So do you think those degrees are for temperature, or do you think those degrees are for angles?
Angles.
Angles. Oh, so sine, tangent, and cosine have something to do with angles. Does that help jog anything in your memoria?
Yes, how I cried through booklet 17 last year.
Okay.
But this year I might not cry.
But guess what? You just said, I'm going to go to this booklet because I know that was there, right? So I can look on my math map and go, I remember it was somewhere in the second semester. Oh, triangles and circles. Oh, that's lesson. Let me go and look at the charts for lesson 16. Right? So even though you don't remember what sine, tangent, and cosine mean, you remember where you saw that. And you know now where to go to look that up. So now I can say to my student, okay, good job. So you know that it has to do with angles, right? And so let's go and look that up. Or we can just say, okay, you're right. Those are hard, but we know that it has something to do with angles. We figured that part out and we're going to see that again. So we're not going to worry about it today. That is your prerogative as the parent to decide how far down into that you want to go. But isn't that a great thing if you just remember that sine, cosine, and tangent have to do with angles and where to look in the math map for that? And we've also, I think it's just as important to be able to look at that and go, well, sine of 67 is on both sides. So I can look at the 2 9ths and the 1/3. That's not uncommon with the high stakes tests like the SAT and the ACT, is to look at things that have a lot of numbers and you really only need a small part of it, right? That instead of multiplying something out, I can see the parts that are similar. So I just want to encourage you that this is a great thing to talk about, even if you don't ever quite get to defining sine, cosine, and tangent. Okay. Jan, I saw you had something to share, but I didn't get to see what it was. Do you want to say it out loud?
If she has problems with her audio, I can read what she wrote.
Thanks.
She said, my daughter and I had a success using comparison yesterday. We were doing the log flashcards. We were stumped by how to figure out the answers when the index wasn't a whole number. Functional answers, and we put them beside each other, compared them. Light bulb. I don't know why yet, but we have the first layer, and I do believe that it will come later and more easily. That's awesome.
That's great. All right. So we have some questions that were sent in. So we're going to not go through the next 2 pages. Notice that what I am modeling for you is that you don't have to dive deep on every page. That you might dive deep on a couple of things each day, and then you're going to be able to say, okay, do the rest that you can. So before we jump into these questions, Babs, can you go back 2 slides? So let's look at teaching classically with multiple domains. I just want to remind you that we start by reading. We can look at the familiar and the unfamiliar grammar on the page. So these are general, right? So I'm giving you more specifics as we go through this, but in general terms, here's how you can look at this when you have multiple students at the table, right? Is look at things that are familiar and unfamiliar. Invite that student who feels that something is familiar to help the student who feels that something is unfamiliar. And then that's when I would say I would break up and take my student who's either, right, whichever order works in your family, work with my unfamiliar students first, stressing the instructions and reading mathematical language, making sure that I'm bringing them to that point where they can assess the patterns and use their skills. Where with my more familiar students, I might say, okay, go and do all those things that are familiar and then go back and start working what's unfamiliar, right? And that's the part I can't help you with because you're going to know your students and how to manage that part of your time. But those are some strategies for having multiple domains at the same table. All right, next slide. Okay, so let's take a look here at our questions. So one of the questions was, how can I differentiate between an irrational number and a transcendental number? That's a really great question. And I don't always have a really easy answer for you. If it is the square root of a number, right, any root of any number will be irrational and not transcendental. Because if I can write the nth power of x equals a number and then solve for x, I'm solving a polynomial that meets our criteria for being an algebraic number. So anytime that it's a root of a number, then it will be not transcendental. It'll be what we call algebraic. There are more irrational numbers, but they are oftentimes, I hate to use the term weird, but they're oftentimes going to be numbers that we generate through using different patterns. So for example, 0.10, 110, 1110, 11110, right? If that would be a transcendental number because it's infinite, but it doesn't repeat. And I'm not going to get that from solving an algebraic polynomial. And so that's the most straightforward way. There will be some, like phi happens to be an algebraic number, not transcendental. So there are some that are a little bit, have names or come from different places. But the biggest differentiator is really going to be if they're roots of real numbers, probably even roots of complex numbers, we would say they're algebraic versus transcendental. And then the rest, it's a little bit harder to differentiate.
So in the scope of the math map, if I find
Yep.
two transcendental numbers we will explore. Or
Yeah,
are there more?
in the scope of the math map, you're going to basically be using numbers that we have memorized as transcendental numbers, like pi and e.
Thank you.
You skipped a bit too fast, Babs. So then another question, I think on that first page was really when we think about a two-term expression can be any two expressions that are added together. It can have absolute value. It can have sine of x. It can have 1 over x, the square root of x. It can have any type of operation in it where I have two terms being added together. Polynomials are very specific expressions. They are have no negative or fractional indices, which means that there's no division by a variable, no 1 over x. There's no square root of x. It will just be x with a natural index, x squared, x cubed, the fourth power of x, and so forth. And then the coefficients are always real numbers. And that's what the definition of a polynomial is. And so when we talk about a binomial being this two-term polynomial, and Lee sometimes adds that word algebraic to really emphasize that we are being strict on our definition there. That's what we're looking for, is making sure that there's no division by a variable, there's no square root of a variable, there's no sine of a variable, there's no, nothing like that. It's just a variable with a natural index and a real coefficient. All right, next screen. So I love this question about absolute value, the determinant, the cardinality, and the magnitude, because that symbol means essentially the same thing in all of those cases. Right? We have all of these different names for different circumstances, but we're always going to be talking about the magnitude. What is the magnitude of a number? What is the magnitude of right, if I'm looking at the difference of two numbers, what's the magnitude of the difference between them? What is the magnitude of the vector? Even with our determinant, we are looking at, it's a measure of magnitude in a little bit of a different way, but it still is related to the measure of magnitude. So I think it's really interesting when we start to look at absolute value and really understand that we're always talking about magnitude. We're just looking at it in different ways. Then natural log and the log base b, or common log, are going to be the three things that we're going to look at. And all we're talking about is what is the base. So if I said the natural log of, and I can't even come, let's say the natural log of x was 3. What that means is that the third power of e equals x. So I would take that for my students and say, okay, write this so that you see the exponential form. So the natural log of x equals 3 means e cubed equals x. If I said the common log of x equals 3, so if there's no base specified, if it just says log x equals 3, that means my base is 10. And so 10 cubed equals x. And then if I said that the log base 2 or 4 or whatever, or base b of x equals 3, then I mean that the third power of b, or b cubed, equals x, whatever that base is. So I think for students to rewrite that in its exponential form is probably the clearest way to help them to differentiate between natural log, common log, and then the log base b.
So just so people know, as the math goes on into higher domains, I've continued to use simple numbers in the power, exponent, and root problems, because I want them to memorize the form and be so confident in it, versus throwing problems at them, which then it's like every other math curriculum. They do it for that week and they don't remember anything. So you see the same numbers, the same form, and the same comparison when we do all the trinity of problems.
As for letting students use a calculator for those big numbers, again, that's going to be up to each individual family. If your student is confident in being able to set up and calculate, and they know how to do the calculation, you might say, I'm happy for you, once you've set that up, to go ahead and use a calculator. If your student isn't confident, or they are not confident doing the calculation, then I would say you need to practice this. So it really is going to be up to you as a parent to determine where your students need practice, where you would expect them to do that practice, especially as they're getting older, and where you might be more content to let them use a calculator for some of those larger computations. And then
The other thing is, these are super simple ones. You just take the number below it and multiply it times 3. And they need practice. We don't, because of space, we don't have a lot of practice of really long numbers being multiplied. So here's their chance.
Babs, do you want to go to the resources page at the end? Because what I said we would do is sort of look at each of these each week. We were going to highlight one thing. And so this week, I wanted to point out that if you are on that main math map page in the companion, and let's say that we clicked on binomials for lesson 3, that would open up that binomials booklet in the companion. And then you can look at, on the right-hand side, if I was to open up the menu, so you'd see the 3 little lines. And if I open up that menu, if I click on chart 1, for example, what I'm going to get is, and now Babs is clicking through, so you can see as I click on each of those things, it's opened up my chart. And if I click where that yellow box is, if I had clicked on there, I would see that information on the right. And so this is where we have those explanations of the concepts for you, that if you're looking at that chart and you want a little bit more information about it that's didactic for you in order to help you ask good questions of your students, this is where you can find that in the companion, is by navigating to those chart pages and clicking on those different sections of the charts to get those explanations. And so now if you click one more time on that slide, they should go away. And I can remind you that we also have the forums, you have each other, and we have the book club. And next week, we will be looking at addition and subtraction booklet 4. So we have just about 1 minute left. Are there any questions that didn't get answered that you would like me to try to answer quickly before we let you all jump over to Latin? All right. Well, if you have questions, please send them in. It's really great when we can actually put help on the screen for you, like we did today, and answer those questions. Those are really welcome. And we hope that you'll come back next week.
Thank you so much.